On April 1st, 2026, at 6:30 p.m., I sat in my kitchen in front of my laptop with bated breath. Joining millions of individuals across the world, our eyes fixed on only one thing: NASA's SLS rocket on its perch at Kennedy Space Center's Launch Pad 39B. In just minutes, we would witness history. A lot of things can go wrong to scrub a mission. Weather, issues with fuel or the equipment, and honestly, more things than I can count. Yet in this moment, it felt like it was meant to be. And, seemingly without a hitch, NASA's SLS rocket boomed off the pad, generating 8.8 million pounds of thrust and careening out of the Earth's atmosphere. For the first time in 54 years, humanity will be returning to the moon. For me, this is such a big deal, not only for the future of exploration and spaceflight, but because it also means that I can now say that I was alive at a time when I got to see humanity go to the moon. And since we are here, let's go over the Artemis 2 mission just a bit more. The time frame for this mission is 10 days, during which 4 primary phases will be achieved. The first of these is to get into an orbit around the Earth. Now, at the time of this recording, this phase has already been completed. Integrity, which is the name of the Orion spacecraft for this mission, will remain in a highly elliptical orbit for a 24-hour period. This orbit will bring it as close as 370 miles away from Earth to as far as 46,000 miles away from Earth. During this time, several critical system checks were performed, as if something had truly gone wrong, the astronauts were close enough to abort the mission and return to Earth safely. Still, let's have a look at some of what had been checked, starting with the proximity operations demo. The purpose of this maneuver is to demonstrate the spacecraft's ability to safely approach and back away from, in this case, another piece of the spacecraft. This will prove that Orion can execute docking maneuvers for future missions and can help NASA confirm that it performs as their simulations predicted that it would. By now, though, you might be wondering, what is their dance partner for this test? And that is where the ICPS stage comes in, standing for, and I might butcher this, Interim Cryogenic Propulsion Stage. This piece of equipment helps Orion achieve its necessary orbit around Earth after the solid rocket boosters of SLS separated. Once the ICPS completes this task, it was also separated from Orion, in which case it was able to serve as the second spacecraft needed for their test. So that is what they backed away from and got closer to. Along with this, the team will test some critical systems, like I mentioned earlier, that are aboard the Orion spacecraft, such as the life support system, which involves ensuring the temperature controls and air scrubbing are stable and operating properly for the 4 astronauts. For those who are curious, the air scrubbing system is what removes CO2 and other contaminants from the pressurized chamber, continually giving the astronauts fresh air to breathe. They will also test their exercise equipment to see how the crew's movements affect the stability of the spacecraft. And they will test their communications equipment to confirm that the crew has access to high-speed communication with ground control. But perhaps more critical than it all, they had to troubleshoot the toilet, which I hear is now in working order. Once all of this was complete, and they could see that the spacecraft was ready, Artemis 2 was greenlit for the next phase, which is exiting Earth's atmosphere and heading towards the moon. In a way, this was the point of no return for the mission, as once they got on that trajectory, there will be no other way to turn back and come back to Earth until after the flyby of the moon is complete. To achieve this, Integrity fired its main engines and performed what is known as a translunar injection. The burn lasted 5 minutes and 50 seconds and occurred on April 2nd, roughly 24 hours after launch. And of course, by the time you are seeing this, that burn has already been completed. This has placed the spacecraft onto what is known as a free return trajectory. This is a safety-first approach, and what it means is the spacecraft will cross the threshold on its own between Earth's gravity and the moon's gravity, effectively allowing it to fall towards the moon. This path also allows it to slingshot around the moon, which is the flyby, and gain enough energy for returning to Earth, even if the thrusters or the majority of the thrusters were to fail later on in the mission. This will also begin the crew's 4-day trip to the moon. During this 4-day period, there are various tests and tasks the crew will complete, along with just general acclimation and gauging what it is like to live and work in space aboard Orion. They will perform additional tests on and fully utilize the flywheel exercise device seen here. This device is a 30-pound cable-based resistance machine designed for use in places with no gravity. As with no gravity, nothing has any weight, so the best way to achieve workouts is through tension and resistance. This will allow the astronauts to keep themselves in the best shape possible while in space. Some other tests they will perform during this flight include a CPR demonstration and practice with quickly putting on their spacesuits. The former will give us knowledge on emergency procedures while in space, while the latter will give us knowledge and give the crew training in the event that the cabin were to experience rapid depressurization. And before we move on, let's touch on that one just a bit. Space is in all ways out to kill us. With no air or oxygen, and nearly zero pressure, if a human were to be out there with no protection, we would die rather quickly. Our blood would boil and outgas, our blood vessels themselves would rupture, and we would have no way to breathe, just to name a few. If this cabin pressure were to be lost, it would fall to the spacesuits to create that environment for the astronauts. And while this would be very dangerous, it would help keep them alive. During the 4-day flight, they will also be participating in press events as well, which I absolutely recommend watching, and I'll probably be trying to leave various links in the description for those who just want to follow along with the mission more. Now let us talk about surely the most exciting part of this mission, the lunar flyby itself. Now this will happen on Monday, April 6th, 2026, and it will last about 6 hours, during which the crew will experience some really cool events. First off, they will be the first humans to ever directly witness portions of the far side of the moon. While seeing this, they will be looking for features such as ridges, ancient lava flows, and craters, which just might teach us more about the moon's formation. And they will be capturing them with high-resolution cameras, equipment, and yes, even smartphones. Really quick, I'd like to touch on what we mean by the far side of the moon. So you might notice, whenever you look at the moon, that it's always the same, right? All things in space spin though, right? So how can that be? The answer to this lies in something known as tidal locking. Most or all the large moons in our solar system are tidally locked to their host planet. And what this is that the moon's rate of rotation matches the rate of its orbit around Earth. So while it is still spinning, the same side of it is always facing the Earth. So when the crew flies behind it, they will see the side that's always facing away from us. I would also like to note that while it is the far side of the moon, it is not the dark side of the moon, because the moon has no real dark side. Instead, it has its own day-night cycle like we do, only for the moon this cycle is a month, so kind of like 2 weeks of day and 2 weeks of night is the regular man's way of thinking about it. The crew will also get a unique solar eclipse experience where the moon blocks out the sun from their perspective behind it. During this time, they can observe the sun's corona, which we really still know very little about. But if anything, I'm excited just to see some of the cool pictures that they're going to get to take during this time. Now, the return trip back to Earth will be similar to the trip out, with demos and science being performed, along with some manual piloting of the spacecraft. One of these demos, which I'm kind of excited to see, will be a test/practice in which the crew builds a radiation shelter out of only the supplies that can be found on board. Because, well, they can't exactly Amazon stuff out to them. And this is so if they were to, face the need to gain additional protection against events such as solar flares, they could put something up in the spacecraft that would do that for them. The final stages of the mission will include the crew module separating from the service module, the trans-Earth return, which is a correction burn meant to line the spacecraft up with the Earth's atmosphere, followed by the entry and splashdown, where a Navy ship will meet up with the crew to pick them up. Depending on what they learn during the second half of the mission, I might do a follow-up to this video. We're going to see how it goes. But to keep this one going, let's talk a bit about the crew members on board, shall we? First up, the mission's commander, Reid Wiseman. Born on November 11th, 1975, he served in the Navy for 27 years, predominantly as a fighter pilot, flying in 3 major operations and logging over 3,000 flight hours that were spread out over 40 aircraft. He joined NASA in 2009 as part of the 20th astronaut class, and he has a lot of experience in space as well, having spent 165 days aboard the ISS. During this time, he completed 2 spacewalks, of which lasted nearly 13 hours, and completed a whopping 82 hours of science, in a single week, a record of its time. Between 2020 and 2022, he served as the chief of the astronaut office, leading the entire NASA astronaut corps, overseeing things like mission training and crew assignment. He would later step down from this position and return to the active flight rotation, where he was named commander for the Artemis II mission. As commander, his duties include general mission decision-making, serving as the primary communicator between integrity and mission control, and operational leadership. But for this last one, his approach is not top-down, but instead empowers and encourages the other crew members to take charge as well. This is something he even mentioned during one of NASA's live events that I was watching the other day. They've been holding these with the press. From what but a simple man on the internet can see, NASA has made an excellent choice in Reid as the commander, and as an experienced pilot, he works closely with our next crew member, Artemis II's dedicated pilot, Victor Glover. Victor was born on April 30th, 1976, and like Reid, served as a pilot in the Navy. He also completed over 3,000 flight hours, and before joining NASA, served as a Navy Legislative Fellow in the office of late U.S. Senator John McCain. He was selected for NASA in 2013 as one of 8 members of their 21st astronaut class. He has completed 168 days on the ISS as flight engineer for expeditions 64 and 65. While there, he conducted 4 spacewalks totaling over 26 hours, and performed things like critical station upgrades and maintenance. From 2020 to 2021, he served as the pilot for the first operational flight of the SpaceX Crew Dragon Resilience. In short, he absolutely has the experience necessary to have been selected as the pilot for Artemis 2. He is also the first person of color to travel to the moon, showing us that behind it all, what really matters is we are all human, and when we come together and set aside our differences, we really can achieve incredible things. He serves as the mission's second-in-command in cases where that is needed, and as the pilot is responsible for spacecraft maneuvering during manual control, and monitoring critical systems during automated control. He will also be auditing the Orion spacecraft and its systems to ensure that it is ready for more complex missions in the future. He will assist in lunar observations during the flyby, and as a former Division I athlete, will conduct even more tests on the flywheel exercise device to help evaluate what ways future crews will have access to for maintaining physical fitness on long-duration lunar missions. Now, let us have a look at the mission specialists, Christina Koch and Jeremy Hansen. Now, Christina was born on January 29th, 1979, and before joining NASA, she worked as a scientific engineer who specialized in remote scientific engineering and space science instrument development. That is a mouthful. She spent a year at the Amundsen Scott South Pole Station, where she worked on high-latitude atmospheric research. And she served as the station chief for the NOAA at the Summit Station in Greenland. She was selected in 2013 as part of NASA's 21st astronaut class alongside Victor Glover, and she possesses absolutely no shortage of spaceflight experience, setting the record for the longest single spaceflight by a woman when she worked on the ISS for 328 days. Wow, between 2019 and 2020. This is a monumental achievement, let me say. Me, who has no right to say anything else. During this time, she conducted 6 spacewalks, totaling over 42 hours. Along with this, she has contributed to 210 scientific investigations. So let me say, she most certainly has the skills to pay the bills. Some of her roles on the mission include monitoring critical systems, especially during phases like the translunar injection and any subsequent trajectory correcting maneuvers. During periods when the crew is seated, like during takeoff and landing, she is closest to the side hatch and as such is the lead for all of its systems and operations, including any potentially needed emergency procedures. She is also responsible for testing and managing the life support systems and the emergency deep space communications equipment. But most importantly, and this was stated by Christina herself, she served as the onboard space plumber who fixed the toilet early in the mission. And in an interview, she even says it just might be the most important thing on that whole ship.
I'll take that one. I'm the space plumber. I'm proud to call myself the space plumber. I like to say that it is probably the most important piece of equipment on board. So we were all breathing a sigh of relief when it turned out to be just fine.
This brings us to the second mission specialist, Jeremy Hansen, who is an astronaut from CSA, which is the Canadian Space Agency. Born on January 27, 1976, he began his career when he joined the Royal Canadian Air Cadets at age 12. There was no way I was that cool at age 12. By age 17, he had earned his pilot's license, and with this experience, he served as a CF-18 fighter pilot in the Royal Canadian Air Force from 2004 to 2009. He remains a colonel in the RCAF to this day. He holds a master's degree in physics, and in 2009, following his tenure as a fighter pilot, he was selected as one of only 2 candidates out of over 5,000 applicants to join CSA as an astronaut. Wow. To train himself for deep space, he participated in the ESA Caves program in 2013, living underground for 6 days, and then the following year in 2014, worked on the ocean floor for 7 days as part of NASA's Nemo 19 undersea mission. In 2017, he took up a leadership role with a NASA astronaut class, being the first Canadian to do so. In short, he really has worked with NASA a lot, and so it is no surprise that he was selected as a part of the Artemis II crew. Now, unlike his other crewmates, Jeremy, this is his first mission in space. Artemis II is his first mission in space. This is something he has highlighted during press interviews. But it is clear to me that he has put in the work to be where he is today. On the way to the moon, his roles are similar to Christina's, as he is the second mission specialist. But as a former pilot, he can serve as a backup for Victor and Reid if it's really needed, and can also assist with decision making in that area. He is specifically trained in manual piloting and star-based navigation, so if the automated systems were to become cooked and just go down, he is prepared to use known celestial bodies paired with a sextant to calculate the spacecraft's positioning and its return trajectory. I am but a simple man on the internet. Yet it is clear to me that this mission is monumental and that the right people were chosen for this task. And a day or so after the release of this video, they will become the first humans to ever see the far side of the moon, and the first humans to return to the moon in the last 54 years. An event that I will be proud of for the rest of my life. Now, this next part really only matters while the mission is still active, but let's go over some ways that you can keep up with Artemis II. I'll be sharing some links in the description to get to NASA's resources, some of the press releases that you can watch, some of the interviews, a lot of the cool things I watched in preparation for this. But the one thing I want to really show off while we're here is this bad boy, the Artemis Real-Time Orbit website, or AROW. And we're going to go through this brief tour while we're here. This is also something that you can repeat on your own. And it's just kind of a fun way to get some information about the Artemis mission. So we're going to hit yes, please. And we're going to go through this. AROW defaults to spacecraft view, allowing you to view Orion as if there were a camera orbiting the spacecraft. How do I become the thing orbiting the spacecraft? That's what I want to know. We can click the left mouse button to drag and rotate the camera around the spacecraft. Scroll in and out to use your mouse wheel and adjust the viewing distance. So we can kind of see here when I scroll, we get a little bit of distance. When I spin, I can see the spacecraft and stuff that's around it, right? So we got Mr. Sun over there. That just might be the moon, but I'm not sure. We'll see that later. There's the moon. Okay. Okay, I should have just read. There's the moon. And you can scroll in and out. We also have this mission view down here, which lets you switch between the spacecraft view and the mission view. The mission view will allow you to view the entire mission trajectory. And so we're going to go ahead and try clicking on it. And this changes us to the mission view now. We are very much zoomed in on Earth. And so this slider is going to let us fix that. If we pull it up, we can see the entire path for the mission. We can see where the moon is. The moon's going to swing in from here. Orion is now closer to the moon than it is to Earth. That's exciting. And we have some toggles down here that let us see different things. So we can click on the spacecraft. We can click on Mr. Moon. And we can click on Mr. Earth, which is where we started. That's why when I clicked this first one, it didn't do anything. And so these will bring you to each part of the mission. And then if you zoom in through this big blue strip, which I must note is not actually in space, then we can get back to Orion. Although if you wanted to go to Orion, you would click on the spacecraft view down here. So, okay, let's go back to the mission view. And it explains the slider, which I just went over, which will help you get more or less of the view depending on what you want to zoom in on. And this is pretty cool, actually. You can click on different cameras, different camera views from the spacecraft. So this, I believe, is only accessible when you are in the spacecraft view. Yet we can see that as soon as it loaded into this, we have this down here. So right now we are on the orbiting view, the thing I wanted to be. I want to be the thing orbiting the spacecraft. Or maybe be in the spacecraft, but let's be real, guys, I'm not that cool. But if we click on these dots, it kind of gives you a view of what the cameras on the solar panels would be seeing. And then you can toggle back. Yeah, the solar array cameras. These cameras represent cameras that are actually on Orion, and we can check those out for some out-of-this-world views. They are disabled prior to launch and during system separation, but they should be active right now, and I will probably see after this, look into where we can actually see real views from those cameras, if that happens to be something that's available. And that is it. That's a little tour. Of course, you can get this yourself from the website just by clicking this arrow. And yeah, I think it's really cool. This is a fun, interactive way to follow the mission. And just something that's really just crazy to me. This is a level of math that, listen guys, I don't have. The moon is moving, right? So it's swinging around here. To do a flyby, Orion had to be on a trajectory that places it in the same place and the same time as the moon. If they were to miss that, I mean, it would be over. They would just out into space and there'd be no getting them back. So a lot of work from a lot of people, besides just the 4 that are on the Orion spacecraft, went into making this mission what I hope to be a total success.